Welcome to our college calculus. The topic for today is continuity. We are talking about the continuity. Okay, we have one question that we have to solve. Where are each of the following functions discontinuous? Right? Okay, we have four different situations. A is fx equals x squared minus x minus 2 divided by x minus 2. All right, the next one is f of x is equals 1 is 1 over x squared if x is different to 0. The second one, 1 if x is equals 0. Next, we have x squared minus x minus 2 divided by x minus 2. All right, if x is different of 2. The second one is 1 if x equals 2. The fourth one question is if x equals this is a degraded integer function. All right. Before the thing before to start our class every day, so I would like to define some main points, some main concept here. So the first one, definition. Okay, definition. All right, so a function, let's see, a function f is continuous so at a number a if limit of f of x equals f of a when x approach to a. All right, this is a concept. How see it in the graph? What's in the graph? And for instance, you have this kind of graph. This is y, this is x. All right, and then we have here this point here, right here. This is a. Here we have here f of a here, and then also let's do the, let me do the graph right here. This is we have one point right here. This graph is running like this way. All right, so in this way it's gonna be running this graph like this. I think it's not clear here. Let me go to the, the point is right here. All right, and then this is y equals f of x right here. You have it, and then right here we have f of x, and then f of a. Right here is approaches f of a. Okay, so here 0, and the bottom we will have as x approaches to a. All right, so it's in this way right here. Okay, here is like this, right? So you have the graph something like this. This is the concept about where is a function f is continuous of a number a if the limit of f of x is equals f of a when x approach to a. Is right here. You have the graph right here. All right, this is x, this is f of x, and that's it. This is, I think, this is the main point. All right, let me erase this idea and let's go to word number 8. And the first one here, notice it that f2 is not defined. So f discontinuous here at number 2. Later we see why f is continuous at all other numbers. So let's see here, write some ideas. F is not defined. Here some concept. F of 2 is not defined. There's 1 point. So this is the other. F is the continuous. F is at 2. Alright, so let's make the graph. This is we are talking about the first one, 8, right here, 8. Problem 8. So 0, this is y, this is x. Okay, let's write number 1 right here, and then 1, 2, and that's it. So here this is the graph. Well, let's use a different color to see better here what is going on. So let's make the graph now. Use the red one. Okay, look at the graph, guys, like that. So here, so here, this is our graph. Okay, this is number 1 right here. So this graph is show our concept. Okay, show our concept, and what I mean, this idea is the picture you can see right here. So F2 right here, F2 is not defined here. This is what I say. So F is discontinuous at 2. F is discontinuous at 2. Okay, that's the first one. Let's see what happened in the number B. So let's go to solution and B. What is going on over there? Here, right here in number B, you have f of 0 is equals 1 right there. Right? Is defined. So here is defined, but but a limit of f of x here is equals a limit of 1 divided by x to the second power, to the second. So here when when x approach to 0, here when x approach to 0, all right, of course. So here does not exist. Okay. This is the idea. Let's see in the graph how it looks this problem, this question, and your graph. So B. So we are talking about B. This is 0. So this is our graph. This is y here. This is x here. So we have 1 point right here. So the graph is not does not exist. Okay, like this. Look at the graph. The graph is to show how to look at number B, right? It's not defined. See, this is the solution for B. Okay, let's go and find the solution in number C. Let's see how to look at number C here, right? We have C right here. C. All right. Here F2. Here F2. F of 2 of f of 2 is equals 1. Okay, this is here 1 is defined. And limit. So here limit of f of x is equals, Here limit is a little bit longer. Limit when here when x approach what? When x approach to. And this one you have x to the second power. This number 3 minus x minus 2 divided by x minus 2. Alright, so this is equals will be equals here equals let's see here, continue here. Limit we will have here, alright, so x minus 2 times x plus 1, alright, divided by x minus 2. Okay, so this is equals, this is will be equals limit, when x here, x approach 2. Here is a conclusion, limit of x plus 1, here plus 1, x plus 1 when x approach 2, so this is equals 3, is 3, right there. So here exists, but here exists. It's a number C. Here exists the limit, right? But what happened here? So limit the number C. So the limit f of x is different of x of 2. All right? When x approach 2, right? So how looks the graph in this question? The graph, look our graph. We have y here, x here, 0. We have 1 point right here, 1 and 2. Let's see, this make 1 point right here. See? And then let's run in our graph. The graph running right there. So here it's broken, the line right there. So the graph looks like that. See, as it exists, but the limit looks different of f of 2. F of x is different to f of 2. All right, when x approaches 2, it's right here. You can see the graph. Right, it's better. See the pictures is more understanding. All right, that was a number C, the letter C. Let's go the last one. The solution for D problem. Here the graded, so here the graded integral, the graded integral function. So we have like this f of x, all right, equals to the sign is a little bit difficult. It's a double here, gotcha. So it has discontinuities. This one discontinuities at all integers because limit here, limit of these integers when x approach to n. So this doesn't exist. So this doesn't exist. Therefore, our graph will be look like this. Let's make the graph right here. Y, x, something like this. So it is very easy here. So we have one point here, and then it's also here. 1, 2, 3. 1, 2, 3. So -1. Okay, it's enough. So you move it like this. Okay, this is the expression that we're talking about here is in the graph. So the second step, the second point, we have another point here. Did you see it? Let's go and then try to make a picture and the other one right here, maybe right here. Right there. See, another one right here. Alright? It's something like this. So this is the picture that represents our concept. The graded integral function f of x is equals the integral x has the continuities at all integrals because doesn't exist. So because the limit of the integrals when x approach to n is not exist. It's not exist.